How to Destroy the Universe by Kurzgesagt. Man, these guys just love to implement existential dread into your mind and just poke at it and make you feel certain ways. How to Destroy the Universe. The heat death? Is that what we're talking about? I guess it really depends. So we watched recently The Last Thing to Ever Happen. And that will inevitably be the end of the universe in any meaningful way. Once there is no change, there is no time, because time is just a measurement of change. So I think it really depends on one key fact. Do electrons decay over time or not? There's also a lot of other key facts, but with the assumptions that we're making going in, or at least that I am, that is the part that I don't know. Do they decay? They have such a long lifespan, we'll never know for sure. But that drastically changes the possible outcome. But let's get right into it and see what's up.
This video was made possible by you. Every sale of our limited edition calendar supports what we do here at Kurzgesagt.
Their calendars are awesome.
Our brand new 2024 calendar is our most spectacular yet. Don't miss out on your chance to earn a special piece of Kurzgesagt
So bright.
history. The universe is going to die one day.
Yeah.
But how?
Oh, so bright.
Well, it turns out our
gotta fix
cosmic
that.
fate will be decided by a fight between two titans. The two warriors deciding the fate of the universe.
Gravity. Oh my god, that
Our
way too
universe was
bright.
born 14...
Jeez. Gravity is one. Okay. And the other is probably dark energy. Which one wins? That's really the big question that we have, right?
billion years ago in the Big Bang and has been
Hello,
expanded
hello.
ever since. For
Chase
some reason,
frags.
New empty space is being created out of nothing between
Welcome.
galaxies. Space itself is becoming bigger. Will
Yes.
it go on forever?
Expansion. Expansion is a crazy, crazy thing. How you doing today, Chase? Hopefully good, good, good.
Or will it stop one day? Today, we think the universe is at the mercy of two cosmic demigods fighting for dominance. The first one is all the stuff in the universe.
Oh yeah, I know.
Galaxies, gas, dark matter.
Ooh.
While they're very different, they just want to do one thing: get together. Matter
Yeah, gravity. At the end of the day, as far as we know, gravity is the supreme force of the universe. At the end of time, gravity is what reigns supreme. As far as we know, there's also dark energy, which is, scary.
is attracted by matter, pulled together by gravity. And gravity also pulls on the universe as a whole, slowing the expansion that started at the Big Bang. Our second one...
I don't know why that scene, for some reason, it just, it just seems dirty. There was nothing dirty about it, but I did not enjoy that scene. I'm doing pretty good for a Monday, I guess. I'm going to watch at least one of these, and then I'm going to go play some Path of Exile. Looking forward to that.
warrior is empty space. While it seems,
Game time.
well, empty and powerless, empty space has an intrinsic energy. We don't really have an idea what this energy is or why it's there. It's really a placeholder that fills a blank
this is
in
a new
our
account.
understanding of reality. But it's got a cool
We just
name,
started.
Dark energy.
Dark energy, yeah, that's crazy. We'll talk about that a little bit. Yeah, we definitely just started this. We have a reaction channel that has quite a bit more traction. We're coming close up on 2,000 subs over there, but wanted to try this streaming thing because I enjoy the interaction. So what's better than live interaction, right? But yeah, what they're talking about here is really interesting, because when you think of empty space, you think it's empty. It's not. There's a lot of stuff going on. There's virtual particles popping into existence and just annihilating each other, which is mind-boggling. And of course, then there's the zero-point energy, which is the actual energy of space, which, because it's even everywhere, can't actually be harnessed. So a lot of people have predictions about free energy. Free energy doesn't exist. You can't use that. Oh, well, thank you. Jose, I'm guessing is how you pronounce that. Jose, fine? 0. Ah, okay. Well, thank you. I appreciate that.
Dark energy pushes
Hope all is
things
well.
apart, a sort of anti-gravity that accelerates the cosmic expansion.
Anti-gravity.
So we have all the matter in the universe pulling in, and empty space in
Stop showing me that scene. I don't like it.
Out.
It's weird.
Whoever wins will kill the universe in fun ways. But who will win? It all depends on the mysterious dark energy. Will its strength stay the same? A common assumption just because it keeps our models simple? Or
Well, the other thing about this, too, is our universe and our ability to observe it is very, what do you want to say? Very minute. We've only been around for a little bit. And we can only see in what's in the observable universe, which, according to a lot of standard models, is very, very tiny portion. So one thing that we just simply don't have the answer for, we think we know, but we don't know for sure, is, are the laws of physics the same everywhere? We simply don't know, and we never will. But it's a good assumption. So does dark energy change over time? No. We've barely observed any of the universe. And time-wise, I mean, we've observed nothing. We can look back, but we're making a lot of assumptions when we do that. We just simply don't know.
will it get weaker, or will it get more powerful over time? 1. Constant dark energy, heat death. If the strength of dark energy stays constant, it will win the war. Since space is growing, matter is getting more and more diluted, like sugar in a cup being filled with more and more tea. But as the universe expands, new empty space is created, which brings more dark energy, which pushes everything apart even more.
It's one of those exponential things. And that's kind of where this comes in, is at one point, does it just rip eventually? Like, can the fabric of space-time just, is there a limit to its expansion to where it's just catastrophic afterwards? We don't know. How do you test that? You don't. You just find out one day, maybe. I love space and universe things. Yeah, me too. It's an absolute fascination of mine. If I was a lot smarter, I might have went into that field, but I don't think I have it in me, unfortunately.
Which creates more empty space, which makes the universe grow even faster.
Awesome.
A feedback loop that will make the universe expand at an exponential rate. Every 12 billion years or so, it will double in diameter forever.
Eventually, at some point, if we assume that our solar system is infinite in its lifespan, which of course it is not, but if we assume for a second that it was, eventually, if humanity survived long enough, the sky would be dark. There would be no stars, because all of those galaxies, all of those star systems would all be moving away from us faster than light. There will be a point in the future where that light just simply can't reach us because space is expanding too fast. That's a scary thought. Of course, us, humanity, will be dead long before then.
But while dark energy is winning the war, matter is winning at least one battle. At short distances, it can keep things together. Local galaxy bubbles can overcome the push of dark energy. In a few billion years, our local group of galaxies will merge into a gigantic ball with trillions of stars.
Man, I gotta fix that brightness. That's driving me nuts. I don't know why, like, my monitor, for some reason, just suddenly locked and won't let me adjust the brightness, which is really weird. So I gotta look into that. But there's a lot of theories on how the universe will die. And one of them is that gravity wins in a different sense than the way I was talking before. So it literally, the universe is expanding and ballooning out. And the theory is that eventually dark energy will get weaker. And the ballooning will slow down and eventually stop. And gravity will overcome dark energy and kind of crush back the universe back into a single point. An anti-Big Bang, if you will. And the idea is that that's cyclical and just keeps happening over and over again. We don't think that that's a likely scenario because there's nothing to indicate that that's necessarily the case, but it is a possibility, and it's something really weird to think about.
It will soon become our last view of the cosmos. All other galaxies will be pushed away by the expansion. For us, it will look like the rest of the universe is rushing away, until in a few 100 billion years, we won't see other galaxies at all.
Yep.
We'll be alone, surrounded by a seemingly infinite dark void.
At least you'd still see the stars in your local system.
All the stars of our supergalaxy will have died out. All gas that could create new stars has been consumed, and no new gas can come in. The galaxy will be dark and filled with stellar corpses. Over quadrillions of years, white dwarfs and neutron stars will slowly cool until becoming truly dark,
Yep.
turning off the last lights of the universe.
That's the black and
All
brown dwarfs we
structures,
learned
big and
about,
small,
right?
will slowly dissolve. One by one, all dead stars and planets will leave the supergalaxy, which slowly dissolves over sextillions of years.
Thank you for the
Every
follow,
object will end
Butrix.
up on its own, which means
Appreciate
that
it.
dark energy takes over again, creating more and more empty space between everything. Objects will be so far apart that it will be as if each had a universe for itself.
That was actually something that I always really wondered is, so the Big Bang, there's a lot of theories on how that actually came to be, what caused it, what was there before. Does space and time have any meaning at that point? And in all likelihood, we will never know those answers for sure. That's just something that we simply won't know. How do you prove that? You don't. But one thing that always has intrigued me is the most likely case that we have is that the Big Bang was caused by a random quantum fluctuation. Given enough time, and we're talking an infinite amount of time, the most unlikely events can hand them through random quantum fluctuations. So the most likely scenario we have is that a random quantum fluctuation in some underlying field probably kicked the Higgs field, which is what gives everything its mass, up. And basically, boom, there was stuff where there wasn't before. But my question is, if that's the case, is that the first time that that's happened? Has it happened before? Was that a quantum fluctuation in an already existing universe that's already expanded to this point that they're talking about here, where everything's just so far away that it may as well not exist because it's just that far away from each other? It's a really interesting thought. Maybe our universe is in the dead shell of an older, a more ancient universe.
Not much happens anymore until in a Google years, all black holes will have evaporated. In the end,
That's a lot of
entropy
time.
and dark energy won't stop until their job is finished. Over time spans you might as well call forever, all remaining structures might even dissolve into single particles that will be pushed away from each other by an ever-growing empty space.
That's
Imagine
crazy.
the whole universe with just a single lonely particle traveling through nothingness.
It's insane.
This is the final state, the true end, the big freeze, or heat death. A completely
Jeez.
featureless, cold, and eternally expanding universe. Nothing will ever be able to happen again. Forever.
And ever.
Whew, well, that was a bummer. What else could happen? 2. Increasing dark energy. Big rip.
Oh, we already talked
What if
about
dark
this.
energy gets stronger? In this case, empty space won't just win over matter, it will literally rip it to pieces. In the Big Freeze scenario, matter lost the war but won some battles. But here, matter wins nothing. Dark energy is growing stronger over time, overcoming the pull of gravity and creating new empty space at smaller and smaller distances.
And of course, there's different forces in the universe. Which forces are stronger than each other at their extremes? How do you test that? That's why we have these theories. We cannot test them. How do you make a lab environment that mimics the early part of the universe?
In this scenario,
Or the late part.
things will escalate quickly. It could start as early as 20 billion years from now. First, dark energy will create empty
Basically
space
a
between
blink of the
individual
eye.
Galaxies. Our galaxy will leave its local cluster and begin to drift alone in a rapidly inflating and ever darker cosmos. Some billion years later, empty space starts to push between individual stars, dissolving the galaxy. If you live on a planet in a star system, the night sky will start looking sad and gloomy, as other stars are pushed too far away to be seen. A few million years after the sky turns dark, dark energy starts to create empty space inside star systems. Your planet is pushed away from its star, and all life in the universe freezes to death.
That doesn't look fun. That looks like living in Michigan. Wow. But yeah, at what point can dark energy overcome gravity? Where's that line drawn, and does that line change? Does the strength of dark energy change? We don't know.
There's not much time left, as a few months later, dark energy is creating empty space inside solid objects. Stars, neutron stars, planets, asteroids, everything solid is being ripped into pieces. If you're on a spaceship, you only have a short time before you are ripped apart. Half an hour later, even atoms are destroyed as new space is being created so furiously that electrons and nuclei are separated.
It's crazy.
Now the universe has just a fraction of a second left. In this final moment, only dying black holes remain, drained and defeated by dark energy. They're tiny, septillions of times smaller than an atom, and they explode with the power of a trillion supernovae in a trillionth of an octillionth of a second. Finally,
a trillionth of an octillionth of a second. Wow. Is there a name for that? How many zeros is that in the decimal place? I don't want to think about it.
The very fabric of reality is torn to its core, obliterating space-time itself. The Big Rip. Space and time have lost their meanings, making it impossible to predict what will happen next. 3. Decreasing dark energy.
The big crunch. Okay, we did talk about that one. We got to talk for a second about the quality of this animation and the music that's going along with it, as well as the narrative. These guys always do a fantastic job, and this one seems to be no exception. Bravo to these guys. They're awesome. I love Kurzgesagt. If they would have shown this stuff in school, boy, would I have learned a lot more.
Big crunch. Poor matter. But there is one scenario where it wins. If the strength of dark energy decreases with time, and if this reduction is strong enough, the pull of gravity will win, and all the things in existence will move towards each other, unfortunately, making the universe collapse into itself.
More friends.
No one knows when this might begin, but it could be as soon as a few 100 million years. What will it look like? As the universe begins to
look at
contract,
this is
over
beautiful.
millions of years,
This is a
galaxies
desktop
and galaxy
wallpaper.
clusters approach each other until they eventually collide. They're mostly made of empty space, so a collision is like the gentle merger of two clouds. At any rate, first galaxies and later individual stars get closer and closer. As the universe goes on collapsing, you might worry about stars and planets eventually crashing against each other. This will happen, but it's not your worst problem. If space itself shrinks, this also concentrates
if you're
all
on
the
that
radiation
planet
emitted in the past by all the stars, supernovae and quasars that ever existed. Now, empty space is filled with radiation. The dark nothing between stars is heating up, making life unpleasant and then impossible as planets just burn. Slowly at
Unpleasant.
first, then rapidly,
Let's go with
space
that.
gets as hot as it was after the Big Bang. Stars are pretty hot, but now the space around them is hotter.
They're pretty
literally
hot.
boiled from the outside. As the universe collapses into itself, all galaxies and all stars merge into a single ball of hot plasma. The Big Crunch is complete.
Wow.
From here on, there are two possibilities. Either the universe will collapse completely into a singularity, a point of zero size and infinite density without space and time.
No. That makes me mad. I don't like that description. So one thing when we talk about singularities in black holes, and it's always been a pet peeve of mine. Keep in mind, I'm not an astrophysicist or anything of that nature, so I am not anywhere near qualified to talk about this. But the way that we mathematically describe black holes and singularities inside of them is not correct. And we know that. We know that that is not a correct representation of reality. But we know that it's the way that we can describe it in math for our calculations to work. It's not infinitely small. It does have a depth, a width, a height, etc. to it. It's just so crazy small that from a mathematical standpoint, it may as well be an infinitely small point because we just can't describe it better than that. But it's not infinitely small. It's not a single point. Ugh. Grumble, grumble.
The way it might have been before the Big Bang.
And it doesn't have infinite gravity, because to have infinite gravity, it would have to have infinite mass inside of it, or infinite energy, because E equals mc squared. Energy and math, or mass, you know. Ugh. I don't like that. And there's no infinite. Anyway, I'm ranting.
Or the universe could bounce back, restarting the cosmic expansion, creating a new baby universe.
That's a pretty cool concept.
Somewhat poetic, really. Everything died, but everything is reborn. But to be clear, we have zero evidence that this has happened before or well in the future. So what will happen? Most scientists think that dark energy will stay constant, so the likely fate of the universe is heat death, eternal cold,
Welcome
and utter
back.
boredom, which seems sad, but has a huge upside. In this scenario, we get to have the universe for the longest.
This is beautiful.
It gives us trillions of years to expand, jump from star to star, maybe even from galaxy to galaxy.
Well, dark energy winning might be the more boring option, but I do think it's the more probable one. And also, kind of like what they're talking about here, it gives the future that life could potentially exist in an absolute insane amount of time that's just incomprehensible to us. So it's comforting to think that in 1 trillion years, there's a chance that there might be a super evolved and advanced civilization that's descended from what is now modern day humans, surviving around a black hole using technologies that we can't even fathom. I don't know. It gives me hope. It makes me happy knowing that the future is so deep and far. There's so much potential there.
We might even find a way to keep consciousness around forever.
That's scary.
So we just have to wait and see, and make the most of the amazing universe we have right now.
We'll find the advanced life form someday. We just got to stop looking on Earth.
Hey you, why don't you stick around for a bit longer? We want to tell you about something that
Are you going to try to sell me
Kurzgesagt
something?
forever.
Yes.
Kurzgesagt started.
So I'm not going to sit and listen to their advertisement, but they're absolutely wonderful, these guys. They make the best videos like ever, man. Super educational, really simplify it down. Highly recommend.